Before I start, one thing I want to tell you. Probably some of you have seen that the club fair is going on in the first floor. We have a number of clubs in our campus here, students clubs. I'm a sponsor of two clubs. One is the science club, very much related to your class. Through science club, we organize a number of events. For example, the cadaver lab 2. It's a very, good event for you to participate and learn the human body, dissected human body. You can see we don't have cadaver lab here, but we take the students to a cadaver lab and show them the body parts, dissected human body, real body parts. So you can see that. You can also see the diseased organs like heart blockage or enlarged liver, all those kidney stones, all those different pathological conditions of your organs. So that's just an example. We organized astronomy night. We took the students and their families, kids, all of them came. We have a basketball court behind this building. At night, we have some very good quality telescopes. So we took all those telescopes there and we try to see the star. Okay? So that is another good event. So all those kinds of events we do here through Science Club. So those who are interested to join in Science Club, please, after the class, go to the table for Science Club and sign. Just put your name, there is a sign sheet, write your name and your email address, okay? We meet once in every 2 weeks, just for a short period of time to plan or discuss what kind of events we want to do, how to do that, those kind of things. And it is very important that outside of the classroom you get a chance to talk to me and discuss the things, right? So we can get more informal way we can know each other. So that is very good. When after you finish your courses, you apply for nursing or any other classes or courses, some of you always come to me to write a letter, recommendation letter, right? So it is very easy, it becomes very easy for me to mention those things if you participate in those things. Everybody comes to the class, right? Comes to the class, and it's nothing that makes you different from other students. So it is important that you participate in some leadership activities. That is important too. Okay. So just consider that, and we have couple of positions open. Like Science Club has a board or a committee, the president, vice president, treasurer, secretary. Couple of students are leaving because they have finished their classes here at this campus. So we have a couple of positions open. If you feel, please talk to me. I can include it. Okay. So just consider these things, and hopefully many of you will sign for the club. Another club I sponsor, that is the Amnesty International. I don't know any of you have heard it. How many of you have heard Amnesty International? Only one? Two? None of you have heard. It's a human rights organization worldwide. It's the largest human rights organization, Amnesty International. We have a club, branch of Amnesty International. I am the sponsor of that club. So we talk about human rights, violation of human rights inside the United States as well as outside the world. Many countries the violation of human rights is being taken place. So we collect the signatures, send it to the president or prime minister of that country to stop those things. So it's a very good organization, okay, to work for human rights. Violence against women occurs. So those who are interested about that, also you can sign put your name there, okay? So we invite a speaker and we collect signatures, campaign against any human rights violations. So all those things will be there. please consider in joining in those two clubs. And also for MST, we sit once in every 2 weeks, just mostly in this room for a short period of time, like 30 minutes, to discuss different issues. Okay. So today we'll talk about, we have finished the human body and orientation. Have we talked about homeostasis in last class? Yeah, we did, yes. Okay, so we have finished that part. So we'll talk about the chemical level of organization of human body. So remember, in last class we have talked about different levels of organization of our body, from its smallest to the highest or largest level of organization. The smallest level is the chemical level of organization. And so today we'll talk about the chemical level of organization. The title of this chapter is Chemistry Comes Alive. In today's lecture, we try to see what does mean an element. What are the elements? Atoms, subatomic particles, isotopes, and radioisotopes. Then we'll talk about chemical bonds. Bonds are attractions between the molecules. So how the molecules or atoms are attracted to each other. Those are the chemical bonds. What are the different types of chemical bonds present in our body? We will see that. Then we'll talk about chemical reactions. You know that many chemical reactions take place inside the body. So how we classify the chemical reactions in our body. Then we'll talk about the organic and inorganic compounds. In our body, two types of compounds are found: organic. Some compounds are organic, some compounds are inorganic. Organic compounds are proteins, carbohydrates, and fats. So those are the organic compounds. So we'll talk about proteins, carbohydrates, fats. Okay? And we'll see what are the important inorganic compounds present in our body too. Then we'll talk about the properties of water. Water, our body is mainly formed by water. So water is the most abundant chemical in our body, most commonly found chemical in our body. So we will see what are the important functions performed by the water. Then we will talk about acid and base. Acid and base, these things you have learned in your intro bio or in high school. So we just briefly revise those things. Then we'll talk about the source of energy. We get energy from food, right? We get energy from food. But what happens when we eat the food is metabolized, right? So metabolism takes place in our body, and metabolism produces ATP, adenosine triphosphate, that provides energy. ATP is the source of energy, right? So we'll see how the energy is used in our body. So first, to understand elements, you need to know a matter. Matter is anything that you see around you. Anything that you see around you is a matter. Matter could be present in three forms: solid, liquid, and gas or gaseous form. You see the solid things around you, all these solid things, these are matter and in solid form. Liquid, water or oil are the liquid things. And gas also is considered as a matter. The main or the most important property of a matter is matter occupies space. So anything that occupies space is matter. could be present in solid form, liquid form, or gaseous form. You know that solid things occupy space. You know that liquid occupies space, right? You also know that gas occupies space. If you fill a soccer ball with gas, right, you will see the ball is getting bigger, right? That means the gas occupies space. So all those are matters. Now, matters are formed by elements. So elements are the building blocks of matters. Elements cannot be split or cannot be broken by ordinary chemical reactions. Ordinary chemical reactions cannot split or break the elements. It is not easy to break the elements, okay? Until today, we have found 92 different types of elements in the earth. So we have found 92 different types of elements exist in nature. And to indicate the elements, we use symbol. And if you see the symbol of an element, if the symbol has two letters, the first letter, for example sodium, the first letter should be the capital or upper block, and the second one should be the small letter. Calcium, first one is capital, second one is small letters. Okay? If we use only one, then it is the capital letter. Carbon or nitrogen, right? We use one letter, and that must be the capital letter. Okay. Now, 92 different types of elements are found in the nature, but you see so many different matters around you, right? In this room, you can find more than 92 different matters. The reason is the most of the matters we see around us are formed by the combination of two or more elements. Make sense? Two or more elements, they join. And not only that, we can mix the elements in different amounts or different ratios to make one matter different from another. Same two matters could have same elements, but the ratio of the elements could be different. Right? The amount of elements could be different. That's why we can create so many matters, or we see so many matters around us. Since we are studying the human body, 96% body mass of human body is formed by 4 elements. Which 4 elements you need to know? It is very important. Oxygen, carbon, hydrogen, and nitrogen. Those 4 elements form 96% mass of human body. Okay? And other elements, those are present in trace amount, small amount in our body, but those are also very important. Remember, although they are present in very small amount, calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine, and iron. So those are present in smaller amount, but those are very important for our body. Okay? So in the test, if I ask you that which 4 elements form 96% of body mass, you need to know that. That is important, okay? Okay, now, if you see the element if you see the element, I told you that elements cannot split by ordinary chemical reactions, but you can see the structure of an element. If you see the structure of an element, you will see that elements are formed by atoms. So atoms are the building blocks of elements. Okay? So atoms are the building blocks of elements. Now, atom has 2 parts. Atom has a nucleus in the center. Nucleus in the center and an atomic shell around the nucleus. So this is the nucleus, and this is the atomic shell. Now, 3 subatomic particles are present in an atom. So what are those subatomic particles inside the atom? In the nucleus, you will find 2 subatomic particles. Protons and neutrons. So protons and neutrons. Okay, in the nucleus you will find protons and neutrons. In the shell, in the atomic shell, you will find another subatomic particle that is called electron. So these are electrons. Okay, so those are 3 particles in an atom: protons, neutrons, and electrons. If I ask you which ones are present in the nucleus, protons and neutrons. Okay, and which one is present in the shell? Electron. Okay. Now, protons are positively charged particles. So protons carry positive charge, plus. Neutrons are neutral. They don't carry any electrical charge. They are neutral. Electrons carry negative charge. So electrons are negatively charged particles. Okay. Here you see the structure of an atom. And you see here is the nucleus, and this is the atomic shell. And this is an electron, negatively charged, this small guy with the small walking with a small dot. So now, when we see the pictures of atom, most of the cases you will see we draw like this, nucleus and a shell. But this is 2D. Just think that in 3D environment there is a nucleus, and the electrons always remember that electrons orbit the nucleus. That means encircle the nucleus, circle around the nucleus like this. So electrons are moving continuously, very fast. Okay. Now, if this is the nucleus and electrons don't move only like this. In 3D environment, just think that one electron is going like this, another electron is going like this, another is going like this, right? So in different planes, they are encircling or orbiting the nucleus. So that's why they have shown different path of the electron. Now, another thing, if I ask you to tie the key with the string and move very fast like this. If you move very fast, you won't see the key. What you will see a circle, right? So now think that what's going on in an atom, many keys are moving in many directions like this, okay? So when you see from outside, it will give you the appearance of a sphere, a ball, okay? And that ball is called electron cloud. Electron cloud. It will look like a ball of cloud, and that is called the electron cloud. Okay. Okay. Now, the weight of a proton is 1 dalton, or 1 atomic mass unit, or AMU. And the weight of 1 neutron is also 1 dalton, or 1 AMU. Electrons are considered as weightless, no weight, because the weight of an electron is so small that we cannot really measure, and it's so small that it's negligible. So that's why we consider electrons as weightless or zero atomic mass unit. Okay. Okay. Now you see they have shown electron cloud that I have explained to you that it will look like a cloud or ball of cloud because of the movement of the electrons in different planes around the nucleus. Now, another important thing about atom is in the nucleus the number of protons and in the shell the number of electrons are equal. That is very important. If what's the charge of proton? Protons are positive and electrons are negative. So if the number of positive in the nucleus and negative in the shell are equal, then the atom is what? Equal number of positive and negative. That means they will cancel each other, right? So the atoms are neutral. Make sense? So the atoms are neutral because of equal number of protons and electrons in the atom. Okay? Equal number of positive and negative. Okay. Now the atomic number indicates the number of protons in the nucleus. So very simple. If in one atom there are 3 protons, the atomic number of that atom is 3. Now the atomic mass number is different. Atomic mass number. If you add the protons, the number of protons and the number of neutrons, that will give you the atomic mass number. Okay. So now, if I ask you how many protons this atom has, how many? Say loud, everyone. 2. So what's the atomic number of this atom? 2. And there are 2 protons. Neutrons. So what should be the atomic mass number? 4. 2 proton, 2 neutron. 4 is the atomic mass number. Okay. Now I told you in an atom is neutral, so the number of proton and number of neutron, electron should be equal, right? Number of proton and number of electron should be equal to make it neutral. Now, if you take one electron out from here, then is it neutral anymore? It becomes positive because there are 2 plus 1 minus, right? So 1 plus is more, right? So it becomes positive. Now there is another atom here and it has, just think that it has 2 protons and 2 electrons. Now if this electron gets out from here but gets attached to the shell of this atom, now how many protons here? 2. How many electrons here? 3. Is it clear? Because it is gaining or getting one more electron from outside. So it will become what? Positive or negative? Negative, because it has 3 minus 2 plus, right? Negative. So by donating an electron or more than one, by donating electron, an atom becomes positive. By gaining or receiving electron, an atom becomes negative. Is it clear? So by donating, an atom becomes what? Everybody. Positive or negative? By donating, it becomes positive. By receiving, it becomes negative. And when an atom becomes positive or negative, they are no more called atom, we call them ion. So this is negative ion or negatively charged ion, This is what? Positive or positively charged ion. So now you know how an atom becomes an ion, either by receiving or by donating. Yes. Ion. So if an atom donates an electron, right, release a negative subatomic particle, then it becomes what? Positive, right? So now neutral atom is becoming positively charged ion. So when the atom is neutral, right, doesn't have any positive or negative charge because of equal number, right, neutral. Now if the atom releases electron, it becomes positive, and the one getting that electron, it becomes negative. Make sense? So when an atom becomes positive or negative, that is an ion. Okay. So when the atom gets electrical charge, positive or negative, that is the ion. Now this process is called ionization. Very simple. The formation of ion, the process of formation of ion is called ionization. How the atoms become ion. So now we know that by donating or receiving the electron, atom becomes ion. Okay. Now, interesting thing here, you see, this one is a positive ion. This one, by receiving electron, it becomes negative ion, right? Now, positive will do what? Positive will attract the negative. They will be attracted to each other. Is it clear? So, an attraction will be created between positive and negative, and that is the bond. Bond is the attraction, and in this case, this bond is called ionic bond. So, how the ionic bond is formed between the atoms, okay? Now, the atoms could have one shell or more than one shell. It depends what kind of atom is that. So, and all shells could have electrons. Anyway, so the atom, this atom has how many shells? 3 shells, right? Outermost shell is called valence. Valence shell. So valence shell is the outermost shell of an atom. So atom could have a single shell or multiple shells. If the atom has more than one shells, then the outermost shell is called the valence shell. Okay, just one. And the electron in the valence shell is called valence electron. Okay. So we have talked about the atomic number and the mass number. We have talked about valence shell and valence electron. Okay, now we'll talk about isotope and radial isotope. Again, I am drawing an atom. This is the nucleus, and this is the shell. Electron here. Here you have proton and neutron. Okay. Now, in an atom, the number of proton and number of neutron are usually same. Usually the number of proton and number of neutron in the nucleus are same in an atom. So if you think that this atom has, let me draw like this, 2 protons, and it should have how many neutrons? 2. Very good, because equal number of protons and neutrons. So 2 neutrons. Now, in some atoms, the number of neutron is different than the number of proton. And if the number of neutron is different than the number of proton, for example, this is an atom, it has equal number of proton and neutron. Now, if this atom has 3 neutron, 2 proton, not equal, right? Not equal. In this case, this atom will be called as isotope. So isotope is an atom that has unequal number of protons and neutrons in its nucleus. Make sense? So an atom can become an isotope if it has unequal number of protons and neutrons. Now, because of this unequal number of protons and neutrons, an instability can be created in the nucleus, an unrest can be created in the nucleus, or kind of high frequency shaking can be created in the nucleus. Just know that an unrest can be created in the nucleus because imbalance can be occurred in the nucleus because the number are not equal, so that is imbalance. And sometimes, not always, in the isotope, because of that unequal number, because of that unrest, the nucleus can emit or radiate, radiation, emit or radiate or send the radiation outwards from the nucleus. And that in that case, if the nucleus produces radiation, in that case, that isotope is called radioisotope. So, you got 3 things here: atom, isotope, and radioisotope. Atoms have equal number of protons and neutrons. If the atom has unequal number of protons and neutrons, in that case, that atom is called as isotope, an isotope. Now, not always, but sometimes, because of that unequal number, because of that imbalance, the nucleus can produce radiation. In that case, if the nucleus produces radiation, in that case, that isotope will be called as what? Radioisotope. Is it clear? Radioisotopes could be extremely dangerous for our body because the radiation that is produced in radioisotope that can cause damage to the human tissue or can cause death of human cells, can kill the human cells, body cells. Make sense? It could be extremely dangerous. Now, radioisotopes can also be used for good purposes in our body. Best example is to kill the cancer cells or tumor cells. We know that cancer cells are abnormal cells. We want to remove them from the body, right? So if you use the radioisotopes to kill, that is one good use of radioisotopes. Okay? Radioisotopes are also used in X-ray technology in harmless manner. We can control and use them in a harmless way to take the pictures from inside the body, okay? Because they can pass through the tissue. Okay. Chemical reactions. Chemical reactions occur due to giving up, gaining, or sharing electrons. I have shown you how attraction between the atoms can be created by donating or receiving electrons. You remember that? By donating or receiving the electrons, the atoms becomes ion, right? I have shown you positive and negative ion, and when positive and negative are created, then attraction or bond is created. So by giving up or gaining, or another thing is by sharing the electrons, the molecules can be attracted to each other and chemical reactions can occur. In case of sharing, if these are two atoms, this is one atom, this is another atom, we know that in the shell we have the electrons. Now, if the electrons in the shell are shared by two atoms, not donating or receiving, but they are attached to each other. So now we can consider this electron as a part of this and this as a part of this because they are attached to each other. So this is called the sharing of the electrons. Not completely getting detached and going to the other, but they are staying on the shell but getting attached to each other. Okay, so we have talked about the ion and ionization, you already know. So, bonds, three types of bonds or force of attraction can be present in our body: ionic bonds, covalent bonds, and hydrogen bonds. Ionic bonds are created, that I have shown you, by ionization. When one atom becomes positive, one becomes negative, then positive and negative, they get attracted to each other. And how that can happen? By donating or releasing and by gaining or accepting the electrons, right? So that is the ionic bond. Ionic bonds are medium strength bonds. That is not very strong, not very weak. Covalent bonds are formed by sharing the electrons. So two atoms will share their electrons. Will not completely get out from the shell, but they will share. And covalent bonds are the strongest bond between the atoms. And most of the bonds in our body are covalent bonds. So the most common chemical bonds are covalent bonds. So if I ask you most common and strongest, that's the covalent bond. Which bond is created by sharing the electrons? Covalent. Which bond is formed by donating or receiving or accepting the electrons? Ionic, right? Is it clear? Good. Now, hydrogen bonds are found between the water molecules in our body. So, water molecules are attracted to each other by hydrogen bonds. But remember, hydrogen bonds are the weakest bonds in our body. So, water molecules are weakly attached to each other, not very strongly. Okay? Okay. So, we have seen that by donating and accepting the electrons, the atoms become positively charged ion and negatively charged ion. Negatively charged ions are called anions, and positively charged ions are called cations. Just know that the negatively charged ions are called anions, and positively charged ions are cations. Okay. And they will attract each other and will form the ionic bond. Here you see an interesting slide. Two atoms are talking to each other, okay? Two atoms are talking to each other, and the first one is saying that, damn, I lost an electron, okay? The second one is asking, are you sure? And the first one is saying, I am positive. Makes sense, right? So by donating or losing the electron, an atom becomes positive, okay? So here you see the ionization, cation and anions are formed, and that's the ionic bond. Here you see covalent bond, two nitrogen atoms, and these are the electrons on the valence shell. And what happens, they get attached to each other. So now both atoms are sharing these electrons. Okay? And that's the nitrogen molecule N2 is formed by covalent bonds between the nitrogen atoms. Okay? And covalent bonds are formed by sharing the shell electrons or valence electrons. Okay, here this is a water molecule, and we know that water is H2O, right? We all know that this is water, 2 hydrogen and 1 oxygen. So these two are hydrogen, this is oxygen. Oxygen is weakly negatively charged, and hydrogen are weakly positively charged. Now, when many molecules come close to each other, the positive hydrogen, weak positive hydrogen will attract weak negative oxygen. And that's how you see the dotted lines, those are showing the attractions between the water molecules. Okay? That's how the water molecules stay together. And couple of ways you can actually observe how the water molecules, you can observe that water molecules are attracted to each other. They try to stay together. If you put your finger in water and take it out, you'll see a nice ball will be formed, right? On the tip of your finger. Why the nice ball is formed? Because the water molecules try to stay together, right? So they don't want to get separated from each other. Another example, sometimes you'll see that very light flies, they can walk on the water. Right? Some flies, they can walk easily on water. Why? Because on the surface of water, you have surface tension. And tension means the water molecules are attracted to each other. Okay? They are attached to each other. That's why the surface tension is created there. So very light thing can walk or run. They won't get inside because the molecules are attached to each other and forming a nice surface tension. Okay, you see an example here nicely. He is sitting on the water surface. Okay. Now we'll talk about the chemical reactions in our body. We know that thousands of chemical reactions are being taken place in our body. We can divide those chemical reactions into 3 types. Some chemical reactions are called synthesis reactions. Some chemical reactions are called decomposition reactions. Some chemical reactions are called exchange reactions. Synthesis means production. Synthesis means the formation of larger molecule from smaller molecules. So many smaller molecules join together to form a larger molecule. That is the synthesis. Okay? Decomposition is just opposite of synthesis. If you break the larger molecule, you will find the smaller molecules. So decomposition, by its name you can guess decomposition. That means you are breaking down. So break down. And synthesis is formation or building or producing. Exchange reactions, the parts of the chemicals will be exchanged. So when two chemicals, for example, let me give you an example of exchange reaction. Sodium hydroxide, if it mixed with hydrochloric acid. Okay? So sodium hydroxide, hydrochloric acid. Okay? If they react to each other, what will happen? This HO will bind with hydrogen here. They will join together and will form what? H2O. Make sense? H2O is water. And this will come here and bind with sodium. So this will go there and this will come here and will form sodium chloride, which is what? Salt. Okay, so water and salt will be formed. Now you see that they have, these two chemicals have exchanged their parts, right? This one is going here and this one is coming here. This is a good example of exchange reaction. So many reactions in our body are exchange reaction. Now I will give you the example of synthesis and decomposition reactions. Okay? Proteins are formed by amino acids. So amino acids. Many amino acids, these are amino acids, many amino acids get attached to each other by peptide bonds. Okay, these are peptide bonds, and they connect the amino acids together and form the protein. So this is a protein formed by many amino acids, right? They get connected to each other by peptide bonds. So when many amino acids are smaller structures and they join to each other and form a large protein molecule. So this is what? Synthesis or decomposition? Synthesis, right? Because it is forming a larger protein molecule. Amino acid molecules are joining together and forming larger protein molecule. So this is synthesis, right? So now if this is protein. Now if you break the protein, if you break these bonds, then what will happen? From the large protein molecules, the small amino acids will get separated. So that is decomposition. You are breaking the protein by breaking the bonds, right? Links. So now the amino acids are getting separated. So this is what? This is an example of decomposition. Is it clear? So decomposition is opposite of synthesis. Okay? Another example, glucose. Many glucose molecules, if these are glucose molecules, they join together and form a larger molecule of glycogen. So glucose molecules, they join together and form what? Glycogen. This is what? This is synthesis or decomposition? Synthesis, right? So glycogen molecule is much bigger than glucose molecules, okay? But formed by the glucose molecules. So this is synthesis. And glycogen is the stored form of glucose in our body. If you take too much glucose, then what will happen? Glucose molecules will get together and will be stored in your body as glycogen. Okay? Now, if you are starving, then what will happen? The stored glycogen will release the glucose, right? So it will be broken into small glucose molecules and will give the glucose to the body, to the blood. So this is an example of decomposition, right? So this is synthesis, and this is decomposition. Okay. So those are three types of reactions mainly occur in our body. Okay. Now we'll talk about the compounds in our body. I told you that two types of compounds are found, the organic compounds and inorganic compounds. Organic compounds include proteins, carbohydrates, fats, and nucleic acids. So those four compounds are organic compounds in our body. Proteins, carbohydrates, fats, and nucleic acids. And other chemicals are inorganic compounds. Okay? For example, water, salts, and acids and bases. Those are inorganic compounds. The main difference, if you see the chemical structure of organic compounds and inorganic compounds, the main difference is usually inorganic compounds don't contain carbon, and organic compounds must have carbon. Okay, so that's the main difference between inorganic and organic. So if I ask you in the test that fats belong to organic or inorganic, what should be the answer? Organic. How about proteins? Organic, right? How about salts? Inorganic, right? Acids, most of the acids, inorganic. Okay. So if I ask you acids, it's a inorganic. Most common inorganic compound in our body is the water. Most common or abundant chemical in our body is the water. Our body is mainly formed by water. Now, 60 to 80% of the volume of living cells is water. That's why I said that our body is mainly formed by water. Now, water has a number of important properties. You need to know those. I'll just go over those. Number one, high heat capacity. That means water can hold lot of heat inside it. That is the high heat capacity. If you put some water in a pot and put that pot on stove and turn the stove on, you'll see, if you touch the water with your finger, you'll see it takes long time to make the water hot. It takes long time, right? Now, after you make the water hot, now you will see that it takes long time to make the water cold. That's why you can drink the tea or coffee for a long time, right? It stays hot for a long time. That means both indicate that water can take a lot of heat inside it, right? To make it hot, you have to put a lot of heat inside it. That's why it took a long time, right? It took a lot of heat inside it. Now, since it has taken a lot of heat inside it, it will take a long time to get it cold. Make sense? That both indicate that water has high heat capacity. It can hold a lot of heat inside it, and that is very important. Why? If water cannot hold heat, if the water easily gets hot or cold, then what will happen in your body? When the temperature outside of your body will drop, because our body is mainly what? Mainly water, right? Our body is mainly water. A lot of water inside the body, right? Now, if water becomes hot or cold very quickly, very fast, then if the temperature outside of our body drops, then the body temperature will suddenly drop. Make sense? Will go down suddenly. If outside of our body gets hot, then our body will suddenly, the temperature of the body will get hot. Make sense? Sudden change. That is dangerous for us. If your body quickly gets very cold or quickly gets very hot, that is what? Dangerous, right? Your body organs will not function normally. Chemical reactions will stop, right? All those things will happen. So that is very important, that high heat capacity prevents sudden changes in temperature in your body. High heat of vaporization. Water will not very quickly turn to air. To do that, you have to boil the water, make it very hot. So with small amount of heat, the water will not turn to air, and that is very important for our body too. Again, our body is mainly water, right? Now, if your body water turns to air very quickly with a small change of temperature, a small increase of temperature, then what will happen? Your body will get big or small? Small. And small means significantly small, very small, right? If you lose the water of your body is mainly water. Now a small increase of temperature, if turns the water in your body into air, then your body will shrink, will get very small, very quickly, very fast, right? But we don't see that happens, and we don't want that to happen. Make sense? So that's why the water high heat vaporization is another very important property of water that protects our body. Okay? Body's major transport medium. We know that the blood circulates throughout the body, and the main component of blood is water, and the chemicals get dissolved in water of the blood and circulates throughout the body, right? So water transports the chemicals throughout the body. A necessary part of hydrolysis and dehydration synthesis reaction. In some chemical reactions, first thing, in most of the chemical reactions in our body, water participates. How water participates in chemical reactions in our body? By hydrolysis and dehydration synthesis reactions. In some chemical reactions, water will split like this, and that is hydrolysis. Lysis means what? Lysis, breakdown, right? So, in some chemical reactions, water must be broken. That is called hydrolysis. Hydro means water. Remember, hydro means water, lysis means breakdown. Breakdown of water will occur. In some chemical reactions, after the chemical reaction is completed, water molecule will be formed. So, production of water. You will see water will be produced. Like metabolism. When metabolism occurs in our body, the end product of metabolism are what? Metabolism produces heat, right? Do you know that metabolism produces heat in our body? So heat is one product of metabolism. Metabolism produces anything else? What's the main purpose of metabolism? Energy, right? So metabolism produces ATPs. Metabolism produces carbon dioxide that is being produced in our body, right? We need to throw it out. And metabolism produces water. So those are the four things are produced by metabolic reactions in our body. So you see that water in chemical reactions in our body, the water is produced. That is called the dehydration synthesis reaction. Anyway, so just know that water is used in chemical reactions in two ways, hydrolysis and dehydration synthesis. Synthesis of water or breakdown of water. Cushioning. Water provides cushion to our body and protects the important organs from physical trauma. For example, cerebrospinal fluid around your brain and your spinal cord, you have a fluid that is called cerebrospinal fluid or CSF. And just think that in your brain, in your head part, you have the brain, and in between the skull is hard bone, and the brain, you have a fluid that is called what? Cerebrospinal fluid, right? And skull is very hard because it is bone, right? Skull is hard because it is bone, and brain is the most soft, delicate organ and important organ in your body, you know that, right? It is very delicate, very soft, and the most important organ. Now, the cerebrospinal fluid between the hard bone and soft brain. The cerebrospinal fluid is in between those two, and that is providing very strong cushion or protection to your brain. When you ride on roller coaster, right, you go Six Flags, and you have seen that how the roller coasters turn from one side to another, one to the other side. So if you didn't have any cerebrospinal fluid between your brain and your skull, then the soft brain would have hit the skull and the damage could have occurred. So it is very important that the water is present in our body in different locations to provide cushion or protection to the important organs and protecting them from trauma. Okay, so those are the important properties or functions of water. Now we will see the acids and bases, just briefly, because this is anatomy physiology class. We don't want to spend a lot of time in chemistry. Yes.
Sorry, real quick. On the end products of metabolism, you said it's ATP, CO2, water, and what was that fourth one?
Heat.
Heat.
Yeah.
Thank you, sir.
You're welcome. Okay. So we will just briefly talk about acids and bases. Acids are the chemicals. Very simplest way. Acids are the chemicals that can donate hydrogen ion. So hydrogen ion is proton. So just know that acids are the chemicals that can donate what? Hydrogen ion. Okay? And bases are the chemicals that can accept the hydrogen ion. That's the simplest definition of acids and bases. Acids can donate hydrogen ion and bases can accept hydrogen ions. Now, this is what? Anybody? Hydrochloric acid. Very good. Why this is acid? Hydrochloric acid is an acid. Why it is acid? Because this chemical can easily donate hydrogen ion. Easily release the hydrogen ion. Makes sense? Easily can release the or donate the hydrogen ion. We don't consider water as an acid. This is not an acid, right? But it has water. But water cannot easily donate hydrogen ion. That's why it is not an acid. So any chemical that can donate the hydrogen ion easily, that's the acid. Now, some chemicals can donate hydrogen ions slowly. Some chemicals can donate hydrogen ion very fast. So which one? Both are acids because they can donate the hydrogen ion. Which one is strong acid? The one that can quickly, fast donate the hydrogen ion. So plenty of hydrogen ion could be donated very fast, right? So that must be stronger acid. Does it make sense? Because that's the definition of acid, right? Who can donate hydrogen ion? Now, two persons is donating. One is donating very fast, and another is donating slowly. So which one is the stronger? The first one, right? So the chemicals that can donate hydrogen ion faster, that's the stronger acid. Okay, so that's how the strength of acid is indicated. Now, the chemicals that can accept the hydrogen ion, those are called the bases. Best example of base, common, is sodium hydroxide. Okay. Now, how sodium hydroxide accepts hydrogen ion and neutralize it? You see here, sodium hydroxide will do what? If the concentration of hydrogen ion in our body is more, then sodium hydroxide will neutralize it. How? It will split into sodium and hydroxide, and this negative will quickly bind with this hydrogen and will produce what? Water, and will produce H2O, water, and will neutralize this. Water is neutral, you know that. So the hydrogen will be quickly removed or accepted by this hydroxide and will produce water, which is neutral. So you see that the sodium hydroxide, which is a base, and it helps in the neutralizing or accepting the hydrogen ion. Okay, so that's why sodium hydroxide is a base. Any question? Okay, so the donor of hydrogen ion is acid. The acceptor or receiver or neutralizer of hydrogen ion is the base. Okay. Now, another important thing, sometimes students confuse that the relationship between pH and hydrogen ion. Okay. So, what's the relationship? The pH is the negative logarithm of hydrogen ion concentration. Negative logarithm means, remember, negative. That means it will go in opposite direction. Negative logarithm of hydrogen ion. So it will go, if hydrogen ion goes up, the pH will go what? Down. Make sense? Negative logarithm. Just remember that it will go in opposite way. Okay? So if the hydrogen ion concentration increases, the pH will go in which direction? Down. pH will go down. Okay? This is one relationship. Another is acidicity. If pH go down, the solution will become more acidic. So this is the relationship. Okay. So pH down means more hydrogen ion in the solution, and more hydrogen ion means more acidic. Because we know that acid means that can donate more hydrogen ion, right? So more hydrogen ion indicates more acidic. Okay. So that's the relationship. Okay. Write it down. This is very important. Sometimes the students, even chemistry students, they confuse that. Okay. Okay. And now the neutral pH is 7.0. That's the neutral. If the pH of any chemical is 7.0, that is neutral. And we know that who is neutral chemical in our body? Water. Very good. So water is neutral. So the pH of water is 7.0. Now, if the pH increases, if the pH increases to 7.8, this is acidic or alkaline? Very good. So pH more means alkaline, pH less means acidic. Okay. So if the pH goes below 7, it becomes acidic. Okay. And if pH goes above 7, that is alkaline or base. Okay. Alkaline or base. So now if the pH of a chemical is 6.0, that is acidic. If it is 4.0, which one is more acidic, this one or this one? Which one is more acidic? 4.0. If the pH is 10, this is strongly alkaline or base. Okay. So if it goes higher, as it will go up, it becomes more and more alkaline. As it goes down, it becomes more and more acidic. So acidic pH is from 0 to 6.99, and alkaline or basic is 7.01 to 14. And that's the range of scale of pH, 0 to 14. And middle, 7.0 is neutral. Okay, so here in this slide you see some uh, chemicals we use in our, some stuff that we use in our daily life, and they have shown their pH and the strength of acid or base has been shown by color. Yes. More orange or red indicates strong acidic, and blue indicates the alkaline or base. Okay. So in the test, I may ask you that the pH of white is 2.5 and pH of lemon juice is 2. Which one is more acidic? Lemon juice, right? Because it has less pH. So I will probably ask a couple of questions from this, whatever I told you, don't forget. I want to ask you without giving you the pH value. I want to ask you wine or lemon juice, which one is more acidic? I'll ask if the pH of wine is 2.5 or 3.5 and lemon juice is 2, then which one is more acidic? So don't try to remember all those names and their pH. Everything hard for you. Okay. Okay. Now we'll talk about the organic compound. Organic compounds are carbohydrates, fats, also called lipids, proteins, and nucleic acid. Okay. And organic compounds must have carbon. Okay. Carbohydrates. If you see the chemical structure of carbohydrates, you'll see carbohydrates have C, that means carbon, H, hydrogen, and oxygen. CHO. Those three chemicals must be present in carbohydrates. Okay. Now we can classify the carbohydrates into three groups: monosaccharides, disaccharides, and polysaccharides. Monosaccharides are the simplest form of carbohydrates. Best example, glucose. Glucose is the simplest form of carbohydrate. Glucose is the simplest form of carbohydrate, and glucose belongs to monosaccharides. Disaccharides, example, maltose. Two monosaccharides join together by dehydration reactions to form disaccharides. So disaccharides are formed by two monosaccharides. Di indicates two. Polysaccharides. The disaccharides join to each other and form a larger compound, that is polysaccharide. And polysaccharide is the most complex form of carbohydrates. Okay? And example, starch and glycogen. Those are the polysaccharides found in our body, the most complex form of carbohydrates. Okay? So in this one, I may ask you that simplest form of carbohydrate. What is the simplest form of carbohydrate? Glucose. Monosaccharide. Very good. And if I ask you, glucose belongs to what? Monosaccharide. Right? And that's why you know that it's the simplest form. So our system, our body can quickly use it because it is simple, right? So that's why if someone has lower blood sugar or gets faint, we give glucose because glucose can be taken by the cells very easily. It's the simplest form. Our body cells can easily take the glucose inside them and use it metabolically. Okay? So most readily form of carbohydrate that our cell can take inside or use is the glucose. The most ready-made form or readily available form of carbohydrate is the glucose. Another question I may ask, that if in a compound you see carbon, hydrogen, and oxygen, that is what? That is carbohydrate. Okay. Now, lipids. If you see the chemical structure of lipids, you will see carbon, hydrogen, and oxygen, and sometimes phosphorus. Now CHO and sometimes CHO and P. Now your answer will change. If I ask you that in a compound you have seen, in the chemical formula you have seen CH and O. What is that? It could be either carbohydrate or fat, right? Or lipids. Now if I ask you the question, in a chemical or compound you have seen CHO as well as P and P. What is that? Lipids or fat. No way it is carbohydrate. Make sense? No way it is carbohydrate if you see P. P must be fat, not carbohydrate. Lipids are insoluble in water, and main types of lipids or main forms of lipids present in our body are neutral fats or triglycerides. We use the term TG or triglycerides. That's the also called neutral fats. Phospholipids and steroids. So those are the forms of fats we see mainly in our body, and triglycerides or neutral fats are the most common among those three. Okay. The last thing today, the fats are formed by fatty acids. If you split or break the fats, you will find fatty acids. And now if I ask you another question, if you break or split the proteins, what you will find? We have talked about that. Amino acids, right? Amino acids. If you break the fats, you will find the fatty acids. And there are two types of fatty acids present in the fats. One type is called saturated fatty acids, and another type is called unsaturated fatty acids. And you probably all are familiar with that idea that saturated fatty acids come from which source? Plant or animal? Saturated fatty acids come from animal sources, and unsaturated fatty acids come from plant sources. Okay? Now, if I ask you which one is harmful for your body? Saturated. That's why when we buy some food, we try to see if it is saturated or unsaturated. Okay. Now, which one is your friend? Which one is your enemy? Unsaturated is your friend, right? I asked this question to another section, and one boy, he said that saturated is his friend. And I asked why. He said it is delicious. And it is true, right? Saturated fatty acids are found in cheese or butter or cream. And you know that all those are very delicious. Okay? So in that way, saturated is your friend, but remember, long-term friend will not harm you, right? If you are a good friend, then shouldn't harm you, but saturated fatty acids can kill you. Okay. So I see you on Okay, again, reminding, the first floor you see the science club table. Please be there and sign.